friends. Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solutions to sequence and series. In today's lesson, we are looking at the second type of sequence, which is geometric progression. We want to look at the concept as well as the formulas involved. Let's look at the concept of this geometric progression or exponential sequence. Uh, geometric progression, geometric progression, geometric progression is a form of sequence. It's a form of sequence. It's a form of sequence which has a common difference, a common ratio rather, which has a common ratio between any terms, and its preceding terms, between any term and its preceding terms. Geometric progression or exponential sequence is a form of sequence which has a common ratio between any terms and its preceding terms. E.g., let's say we have 2, 4, 8, 16. Observe here that when we say 4 divided by 2, we're getting 2. When we say 8 ratio 4, we're getting 2. When we say 16 ratio 8, we're getting 2. So they have the same common ratio. It means if we say thus this is first term, this is second term, this is third term, this is fourth term. If T2 divided by T1 is equals to T3 divided by T2 and is the same as T4 divided by T3, then this is what? Then this is geometric progression. Let's look at this concept. 4 divided by 2, that's T2 divided by T1, we're getting 2. Third time divided by the second time, we're getting 2. Fourth time divided by the third time, we're getting 2. So meaning this is geometric progression. And the difference is what we call common ratio, because it's T2 divided by T1 is the same as T2 ratio T1. So this is the concept. Okay, very important. So let's analyze the formulas, all the formulas involved. Number one, the nth term of GP. G for geometric, P for progression. The nth term is given as the term now will be A R power n minus 1, where A is the first term, R is the common ratio. R is the common ratio. N is the number of what? Number of terms. N is the number of terms. Very important. Okay. That is number one. Number two, the sum of geometric progression when the common ratio is greater than 1. Very important. Sum of GP when R, which is the common ratio, is greater than 1, is given as sum now will be equals to A into R power n minus 1 divided by R minus 1. This is when the common ratio is greater than 1. Very important. Let's move to the second to the last. That's number 3 now. The sum of what? Sum of GP when the common ratio R is less than 1 it will be sum now, which is the opposite of this. It will be a into 1 minus r power n divided by 1 minus r. This is when the common ratio is less than 1. The last but not the least, sum of GP to infinity. That will be the last formula. Sum of GP to what? To infinity. Sum of GP to infinity is given as sum to infinity now will be equals to a divided by 1 minus the common ratio. So these are the key 4 formulas as far as geometric progression is concerned. In our next video, we'll look at how we can use these 4 formulas to solve as many questions as we can as far as geometric progression is concerned. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ Smart Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. Thank you for watching. See you in my next video.